So looking at exponential equations, we've been looking at exponents a lot. Now where this is leading, is to exponential relationships. So far we've talked about a linear relationship, which is like something that's directly correlated. So if I'm walking like 5 kilometers an hour and I walk for 2 hours, I will have walked 10 kilometers. If I walk 3 hours, I will have walked 15. It's a straight line going up on some sort of angle. It can be straight sideways or straight up and down, but it's a straight line. There's no curve to it. Then we talked about quadratic relationships, and that's where we have kind of a parabola. That's like throwing a ball. So it almost looks like a bowl or a big hill. So it's that ball or that hill shape. So the parabola, it's like a cup. When we're looking at those, if I just gave you a table of values, the one thing that we need to understand is that the first differences in the table of values, if they're all the same, it's a linear relationship. If the second differences are all the same, it's a quadratic relationship. Well, now we're going to take that one step further and we're going to look at exponential. Okay, so an exponential relationship is always going to have the equation something like this, where the exponent is actually our variable. Okay. Now we're not looking necessarily for the differences. So if I gave you a table of values and asked you like, what is this? You would do your first differences, and if they're not the same, it's not linear. Then you do your second differences. They're not the same, it's not quadratic. Then what you would do is you actually divide up the table. So you're going to divide up the table and it should be all the same numbers. This is called a constant ratio. Okay? And if they're the same, then it's exponential. Okay, the graph is a curve. It almost looks like half a parabola, but it's a curve that flattens out at one spot. So if you look at these, it flattens out at one spot. This is really common in like bacteria growth or other things like that. And there's like a lot of business examples that look into this kind of thing, like making money and things like that. So what we'll do is we'll do a couple examples. I'm just going to make it a little thinner. Determine which one of these are linear, quadratic, or exponential. So the first thing we need to do is we need to divide up the table. So we need to find our first differences, our second differences, and then if neither of those work, we're going to find our common ratio. Okay? So our first differences, all we do is we're going to start at the bottom. We're going to do 24 minus 17. We get 7. Then we're going to do 17 minus 12. We get 5. 12 minus 9. We get 3. And then 1. And then negative 1. And then negative 3. So those are not the same. So therefore this is not linear. Okay, I started at the bottom y value and I subtracted the next number. That's the first difference. Now I'm going to do the same thing again, but I'm going to look at the new numbers. So I'm going to do 7 minus 5. I get 2. 5 minus 3. I get 2. 3 minus 1 is 2. 1 minus negative 1. Well, that's like 1 plus 1 because 2 minuses. And then 2 again. So therefore, this is a quadratic relationship. Alright, well, let's look at the next one. Okay, so the next one. Okay, negative 26 minus negative 21. Well, that's like negative 26 plus 21. So that's negative 5. Negative 21 minus negative is like plus 16. So that's negative 5. And if you were to go up, you're going to notice that all of these are going to be negative 5. Now the first differences are the same, so therefore this is linear and you can stop. You don't have to do any more work. Alright, now this next one. If I look at this next one, I can kind of tell that the first differences aren't the same. I'm going to go through all of the steps because some of them are similar, but I might start checking the ratios with this one. The reason I might start with that is because the numbers at the bottom are so small and the numbers at the top are so big. Okay, but we'll go through and we'll check our first differences, our second differences, and I'll show you that this one is going to be a exponential equation. So that's that. This one is 2, 7. This one's negative 2.7. This one is negative 27. And you'll notice that all of these numbers are pretty much the same. The decimal has just moved over. Okay, well now we gotta do it again. I'm actually going to change color when I do the ratio just to make it nice and clear. Otherwise, I think what we have here might get a little bit messy. So we got 2, 4, 3, and then this one's going to be 2.43. This one's going to be 24.3. And you notice we were negative here, but then when I was subtracting up the table, I'm actually adding a number, so it's becoming all positive again. Okay, so when you subtract a negative, you always become positive. 2, 4, 2, 0. Okay, so first differences were different, second differences were different. So we know it's not quadratic or linear. We've got way less numbers, but we're going to go back right to the start. Okay, so what I'm going to do is I'm going to, I won't erase it. We'll just do it on the other side. Okay, so what we'll do is we'll go 0.03. So I'll put it way down here. So we're checking the ratios. Okay, so I'm doing all of the ratios from this column. You can actually choose any column. I choose the first column because it actually tells me what the value is that I'm going up by. So 0.003 divided by 0.03 gives me 0.1. 0.03 divided by 0.3 gives me 0.1, 0.1, and I'm using the column that I've highlighted. I know that it's a little bit far over here, but what it means is that if I were to start at the top, the next y value, so therefore this is exponential, the next y value is determined by multiplying the previous one by 0.01. Alright, so looking at this example, whoops. So we've got a colony of bacteria grows exponentially. The rate at which they grow remains constant over equal periods. A colony starts with 50 bacteria and triples every 5 hours. Complete the table of values up to 2 days. Okay, so the table of values up to 2 days, so we've got 5, 10, 15, 20, 25. We're just going to stop there. We don't need to go up to 2 days. We'll go up to the second day. Okay, we've done the whole first day. Because it's going to be tripling, what we have to do is we're going to start with 50 bacteria. At time 0, we have 50. Now we're tripling that. So all we're doing is each y value, we're timesing it by 3. So here we've got 150. Then we times that by 3, we get 450. Times that by 3, we get 1350. Times that by 3, we get 4,050. Times that by 3, we get 12,150. Okay, now it asks approximately when do we get this. So I'm going to do that before I sketch it. Well, it's right here. It's kind of in the middle of this. So I would say between 15 and 20 hours. And it's probably closer to 15 hours than it is to 20. So you could say 2,000 bacteria around, let's say 16 hours. Okay, because 1350 is closer to 2000 than 4050 is. So I'm just choosing it. You could say 16 or 17 and you'd probably get the marks in both cases. Okay, now if I were to sketch this graph, here's the graph, and we're just sketching it. It says to just do a sketch, you're not doing an accurate graph. We know we're starting at 50, so we're not starting quite at 0. And then what we're actually doing, so we've got bacteria on the Y, and we've got time down here. What it's actually doing is it's going up like this. Okay, so it's going up exponentially. It starts to go up faster the further you go along. If you look at the bottom, it went from 50 to 150. Well, that's only a jump of 100. Well, then the next 5 hours, it's jumped by 300. And then the next 5 hours after that, it's jumped by 1100. And it's going up a lot faster the further we move along. Okay, so there's that question. Now the last one. Okay, so there's two graphs of each. There's 6 graphs and we have to match them all up. Okay, I'm going to start with the quadratics because I do think that that's the easiest one. And then I'll do the linear and then we'll look at the exponential. Okay, so we'll just color code them. So this graph here, this is a quadratic and it's facing up because it has a positive a value. So all I need to do is find the bowl that has a positive a value, and it's right there. Okay, the next one, we'll try to make this as easy to see. I'm going to look for the quadratic that's facing down. So I'm just finding the bowl that's facing down. Next, we'll do the linear graph. Now this one's going up to the right because it's got a positive m. So the slope means that it's increasing, it's going up to the right. If it had a negative m, like the second last equation, it would be going down to the right. So this one's going up to the right, moving right across. Now we're looking at this one. So now we're going down to the right. Okay, and then finally we've got our 2 exponentials. Well, the one that's increasing, the one that's getting bigger is this one. So that's what we just kind of did. So we know that that's this graph because it has a positive x value. Now if it's decreasing, like this negative x value, we would have this one where it's getting smaller as we move along. Okay, so I hope that that is kind of straightforward. We'll look at it a little bit more next day.